We'll talk about hydrodynamic modeling in environmental impact assessment. I am Abdurrahman Nassar. I'm PhD Marine Ecology and CM. And thank you for your attendance today. I hope it's going to be like informative session for you about this. So let's go on. By the end of this session, you should get like an idea about the fundamentals of hydrodynamic modeling and also about the modeling itself. And also the role of this modeling in EIA studies. And we're going to have a case study just to have an example for what we're going to say. So first, what is modeling? Modeling basically it's mathematical equations. So all this software that we use to create our models, it's just interface for equations, calculus equations that solve equations of different variables and detect the change of these variables by time, by other factors, whatever the model that we are doing. So it's basically about each measure that change of variable in for other factors. For example, time, flow, whatever the model that we are doing. And the application of modeling now is wide range. It's in physics, economics, biology, engineering, and today we are talking about environmental impact assessment and the role of the modeling in it. It's very, very important now because most of environmental agency or organizations that reviews our EIAs now asking or required including modeling in our study, and they review it very well because it's something scientific, something mathematically proved, give us an idea what is gonna happen in our project in future. So it's very, very important. And we have in EIA, we are most of time we dealing by two types of modeling, air modeling and hydrodynamic modeling. And today we're talking about hydrodynamic modeling. So when we say hydrodynamic, hydro, it's like a fluid, and in this time or in this session we are talking about water, and dynamic is it's equal motion. So basically, it's a mathematical representations of water movement. So it's depend on two laws. This one, it's about mass. First one is about mass, which is include density as a variable and the velocity vector. And the other one about momentum, which is about pressure, dynamic viscosity, gravity, acceleration. And there is another equation about energy. So all of this is a fundamental equation for all model that we use in hydrodynamic modeling. There is different types of hydrodynamic modeling, depend on the purpose that you are doing in your project. So we have 1D model, 2D model, 3D model. 3D model, we simulate for different layers. For example, if we have a power plant and this power plant discharge a high temperature water into the sea, and this power plant discharge on depth, for example, like 5-meter depth, and we need our model investigate the dispersion of this high temperature water in the column of water. So we are talking about layers. But if we are talking about the sea surface, For example, the same power plant will discharge directly on the sea surface. So here we might talking about 2D model would be enough for this. Okay, also 3D model would be perfect also, but 2D model it will be enough for this. So we have different type of hydrodynamic modeling, depend on the purpose of the project. So what is requirement data for modeling, for hydrodynamic modeling? First, we should have bathymetry data. We are talking about water body, and this area should have depth data. So this bathymetry data, we can get it from field survey, bathymetry survey, or we can get it online, or we can do both. We can get it from bathymetry from field, or we can do get it from online. And we can compare or validate the data by comparing the online one and the field one and make a validation for our data. Boundary condition, this is the boundary that's surrounding our project area. So we're doing the model in a specific water area, and the outside model, this is a boundary. So we should have the data of the boundary, which is a boundary condition, which is like tide, which is might be a tide or ocean or wind or sea level or whatever the condition outside, because this is to control our boundary of the boundary of our model area. Third thing, tides. Tides is very important data. We should get it from field or online also, but most of the companies, they required to get it from the field to get an actual data. So basically, we drop down ADCB, which is the instrument that can detect the current and the tide and give us like a data, and we can validate this data by online data also. Wind data, it's important here because we are talking, it's a impact or effect on the sea surface. So it's very important here about the direction of the wind in the project area or in the model area. The speed of the wind, and if they're changing in all of this parameter, wind parameter or wind data during the year, we should consider it. Also, roughness coefficient and sediment properties, it's important in some cases. So this is a requirement or require input for data. So what is the output? The output from hydrodynamic modeling, it could be like maps, 2D or 3D map, like this bathymetry map, or a graph like this graph that's giving us like the change of current speed in time. What is software? Software that we can use to make hydrodynamic models. We have several softwares, but Delta 3D and the Mike is most popular. Delta 3D is free. It has like some version free. Mike is totally paid. And also we can deep more inside one of them if you mentioned in the comments in LinkedIn that you are interested to know more about technical stuff. So we can like choose one of them, most probably like Delta 3D because it's free. So just like let me know in the comments on LinkedIn. So what is the rules of hydrodynamic model in EIA? This is the question of our webinar today. Actually, like hydrodynamic modeling, it's a very helpful tool for EIA engineer or expert to assess the potential impact, and then they can put or they can do like mitigation or this stuff. So it's very important in many cases, especially thermal salinity dispersion, flood risk, coastal construction effect, coastal erosion. We can do several things for different purpose using hydrodynamic modeling. Okay, so as an EIA expert or engineer, the modeling, it's starting from my point, not from the model engineer actually. So baseline data collection should be going on through you at the beginning, and to get all of the data from the field, weather, bathymetry, water levels, water chemistry, everything. And then I start to talk to the model engineer, or if you are doing the model by yourself, so you'll start to putting scenarios. Scenarios, it's we doing different cases. We create different model to simulate different scenarios. For example, if we are talking about like temperature dispersion or thermal dispersion, so we must consider if in a place like Egypt or Middle East, we should consider like summer season and winter season. So here we have two different scenarios at the beginning, and we could have more scenarios. So to set up a model, first we should make a scenarios, and then we set up our model by generate a mesh. What is a generator mesh generation? It's like we convert the map of the area of the project area or of the model area into a point which each point has a unique coordinations, and we can deal with these points mathematically. We will see it in a case study now, but let's finish this one. So we create a mesh, and we input our boundary condition and other parameters, and then we can doing calibration for the model, validation, and each of this step is taking big time to validate data, calibration, and it has a lot of details. So this could be like a big course, like several sessions talking about modeling itself as a technical way. But for now, after we doing all of this and we get the result, we give the report to the impact assessment expert, and this engineer will look at the report and reading very well and get a conclusion, which is what is the impact of the project on the environment, and then puts a mitigation about this. We have a case study here to make things clear. We have a power plant, and this power plant discharge high thermal water into the sea. And the client told us like, okay, we have two options: discharge this on surface or at -2 meter depth. So here we got this information that we have a flow of discharge and we have a temperature, and we should collect the other data, that's wind, tide, that's all that we mentioned. And we doing scenarios, which is we should have summer and winter scenarios, and we have surface and 2 meter depth scenario. So we have total 4 scenarios for our model. We should check all the results of this. After we input our data and run our model and give it a time, we of course here this is a mesh that we convert the area of the project two dots, so we can deal with it mathematically through modeling application. Of course, I deleted the coordination just not to refer to the project, but you should have coordination here. We represented through the model, we represented the bathymetry data. So we see here, we are talking about discharge in this area, which is around the 5 meter or average 5 meter here. Here our result, and this for summer, and we have this upper map. It's for surface discharge. Down it's for a -2 meter depth discharge, and we can see there is no such difference in between both cases. And we have here a coefficient that's differences coefficient. This is very, very low, so we can say there is no differences, or the differences is very very low. Also here for winter, the upper one for surface discharge, the down one it's for -2 meter depth, and also there is no such differences here. So from this output, we got so many information. First one, there is no differences between surface and -2 depth, so we can use both of them. We have here different dispersion between summer and winter, and we should detect the radius of this dispersion to make sure it's compatible, or it's a compliance with the regulation of the country, or the regulation that's you doing EIA with it. So we got a lot of information from the modeling, predict about the dispersion of the high thermal water from this project, and we can investigate now the impact assessment and the potential impact, and then we bought our mitigation. This was like a quick presentation about the relation of between hydrodynamic modeling and EIA. Not so much technical stuff about modeling, but as I told you, if you are interested about have more details about the technical stuff about hydrodynamic modeling, we can choose one of the application. We can choose Delta 3D, but just like let us know in comments about if you are interested about this, so we can organize this later, inshallah. Thank you so much. Please, if you have any questions.